Welcome to the OOP, Object-Oriented Programming, and Class Basics tutorial. The first thing that we're going to do for this tutorial is start with a brand new project, which you do through the File, New Project. And you want to select under Templates, Visual C#, Windows Classic Desktop, Console App.NET Framework. This is the option that you use for all of the projects you'll do in ASD. And you'll want to name it OOP and Class Basics Tutorial. I'm not going to complete the process. I've already created the project, as you can see in the background here. So once you've done that, you can go ahead and get started. And we'll cover several topics today, building upon what was covered in the review for the review videos. So the next thing we'll do is talk about method overloading. And for this, as far as the code goes, we're going to start with the getInt method from the methods video. Just go ahead and create an instance of it here. You can go ahead and copy it if you have the code handy. I'm using some shortcuts, should have been covered previously, but CW, tab twice, will insert a console write line. With the text being displayed, we want it to stay on the same line, so we'll just use a console write. The effect of this is the cursor, after it prints the message, will stay here on the line instead of dropping down to the next line. Just makes it a little more user-friendly, looks a little cleaner, looks like you're actually responding to the question. So with this method, it provides a handy way to just prompt the user and have them get an integer, and using the try parse in a loop here like this, if they don't enter a valid integer, it'll keep prompting them to enter one, which is nice. But what if we want to force a range check or something like that? We only want numbers between 1 and 50 or 1 and 10. In order to do that, we're going to define another method. But to make things easier, there's a concept called method overloading, where you can use the same method name, same return, and as long as the method takes different parameters, then the compiler knows which version to call, and you can have multiple methods and just call them all with the same name. The version that gets called is controlled by what arguments are passed to the method when you call it. To do that, we're going to declare another method here called getInt. With this one, we're going to add a min and a max. Copy this because it's almost exactly the same. main difference is we're going to add another check here. Let's see. We will include the values passed in, so main and max are included as valid values. And the last issue here is we still need to declare the string. So this is going to try to get a valid value. If it is valid and it's in the correct range, it will say true, which would normally loop, but we're negating it to false, so that will exit when we have a good value. Otherwise, if it fails this part, it will be false, come out and be made true. If it fails this part or this part, then it'll be false and be made true, and we'll keep asking them to enter a new integer. So with method overloading, it's a form of polymorphism called operational polymorphism, and it's because you change the way the method or the program behaves based on how you call the method. You can show this by calling the getInt methods. So we'll do that in main here, and we'll use string interpolation when we display the results. So you'll see the only difference that we're going to, between the way we handle these, is the arguments that we pass to it, and that tells the compiler which version we're going to call. We'll then display the results here. I use string interpolation, which starts with the $sign before the string. What that does, that tells the compiler to evaluate any blocks like this when it goes to display the string and place those values, the values that result, inside of the string itself. So you can put just a variable in there. You can actually place an expression, something has to evaluate, as long as it ends up resulting in a value that can be added or converted into the string. And then add 2 lines at the end here so that we can run with debug. And all these 2 lines are going to do is display a message. It says press a key to continue, and then it's going to wait until any key is pressed. That way, when you run with debug, if the program reaches the exit point, it doesn't keep the window open, it closes everything out. This will keep the console window open until we've seen the result. We press a key, and then it'll close out. So if we go and run that, so we can see the output. Just take a second to compile. Our integer, we'll say 42. Our integer. You will note that this is not the most helpful, so we could say 100. It's an integer. It could look like an infinite loop, so we should probably upgrade the message. Meantime, we know it's supposed to be 1 and 10. We'll test a couple bad values just in case, and then we'll or it's between 1 and 50, then we'll do 49. So here, number picked was 42, that was our first one. Value between 1 and 50, we picked 49. So let's make these a little more useful. And to do that, we will use optional parameters. What an optional parameter is it's a parameter for a method that's been given a default value, so that you can call the method without supplying a value, in which case the default value will be used. If you supply a value, then it'll ignore the default and use the value that's passed in. So for getInt, the second one, let's go ahead and add a message or a string called message. And then instead of displaying enter an integer, we'll display message. And then we'll add a default value so they don't have to supply it. Like that. By doing that, this part here, the fact that we're assigning a default value makes this parameter optional, which means the call here is still fine. If we didn't have that, you would see an error on that line. So I just cut this out. Let's save it. You'll see an error because we're not providing an argument for the parameter message. I undo it, put it back in. It's happy again. We don't have to supply that value. It is optional. Now for this to be a little more useful, we will supply a message though. So by doing that, taking advantage of the message parameter, we can include a more meaningful message. In this case, we're actually telling them the range we expect the number to be in. And when we run it again, now we'll see the first one's just asking for anything, so we'll put a big number. Second one tells us the range. We're gonna try to break the program, say, oh, 51, no. How about -1? No. How about 0? All right, let's try 1. That one works. See, we pick the number, big number, and then pick the value between 1 and 50 was the value 1. Let's go ahead and also, we'll do the same thing for getInt to make it a little more useful. Make sure you change the line here to display it. Since it's optional, we don't have to change the call. It'll display the exact same way that it was. Now, one limitation to be aware of with optional parameters is that they have to be assigned from the rightmost, in this case message, moving left. We cannot skip one, so I cannot assign a default value to min without first giving max a default value. And if message didn't have a default value, then max could not have a default value. So you have to start from the rightmost and assign it a default value if you want one, and move left. If for some reason you wanted max to have a default value and message to not have a default value, you would actually have to switch the order, or you couldn't do it. You could have the parameter order be int min, string message, int max with a default value, but that would be the only way to do that. Or that, or since we do have a default value, then we can actually go and say max by default. If we don't say anything, will be 100. But let's just leave that with the message being the only thing with the default value. Now the next item to talk about takes methods to another level. So far you've worked with the main method. Most of your code's been here. Towards the end of the first set of videos, you started creating methods, like the version of getInt here. Classes take things to a whole other level. A class is actually a custom type that you define that groups related variables and methods together. The way you use a class is the same as you would any other type, like int or float or string. So the setup for representing some stuff with classes, let's go ahead and ask the user for some information. So we'll ask the user for their name. So I'm going to ask the user for some information that we would use to represent that user. Here, to make it a little more personable, we'll actually use string interpolation and put the user's name in here. For one more piece of information, let's go and ask them their age as well. We'll take an integer format and assume the user has to be between 18 and 120 years old. We need string interpolation here as well. We'll put the name in there again. This will do 0. So I'm going to change this to allow 0. So we have this information, and if we only had to represent a single user, that would be fine. If you're starting to write this program and your boss comes by and says, okay, we actually need to support hundreds of users or thousands of users, you don't want to create a bunch of variables and have it be like name 0, name 1, name 2, name 3. Also, if you just do a bunch of arrays, which is what they used to do, then you have to coordinate between a name array, an address array, and an age array. It just becomes kind of a pain, so it's a little easier if we can group that together. And we will do that by creating a class. And the class will simplify the process of creating the variables holding the data that we need. To create a class, there's a couple ways you can do it. You can do control, add, new item. You see the shortcut. This is the method I prefer, is Control Shift A. So if we click into new item, you'll see this menu here. If I close it, if you remember the shortcut, Control Shift A. Select the template for class. You can double click. It doesn't matter if you get rid of the .cs extension, it'll be appended anyway. Let's create a class called user. Down here, this will be the name of the class. An empty class called user. Define to the computer exactly what a user is. And this is a point where I want to stress that when you're creating a class, an interface, or anything else you'll learn about later, every single class and interface should be in its own file. There's no exceptions. There's no reason to ever put more than one class in a single file. It's something that you'll see in some online tutorials. It's because they're trying to do a video, they're trying to do it quickly, and it's easy. It's a bad coding practice though, so it's not something you should do. You should always create each class and interface in its own file. You'll see by using that the template. If we look over here, program, this is the main part of your program. This is where your main method is. And user.cs, this is your file that defines what a class user is. So classes specifically are used to group related bits of data. If we look back in program, we ask for the user's name, address, and age. These are bits of data that we want to store as part of a user. And we do that by creating what are called fields. And a field is a variable that's associated with a class. And they're created inside of the class, but outside of any specific methods within the class. So to create a field, let's go ahead and do string for the name. And personally, I like to use an underscore so that when I'm working with the variables, I know which ones are members of the class or fields of the class. And we'll do address and the age. So now we basically have created a container that can hold a name, an address, and an age, which conveniently matches what we needed in main here, the name, the address, and the age. Now right now, if we actually create a class in main, we wouldn't have access to these items because they are private by default. The way to fix that is to create methods so we can get and set the values. These are called getter and setter methods. So for each of these, we'll create a get and a set. So for a get, it needs to return the item. Typically you're going to use get or set as part of the name, just to make it a little, basically make it blatantly clear what it's doing. And with a setter, you don't return a value. All you're doing is changing the one in the class. You have to take the new value in that you're going to set and make sure you assign it to the class field. So this is the value that's passed in, and we're assigning it to the field that belongs to the class. I'm going to click the minus sign here. It just minimizes the code. You see the 3 dots. The code is there, it's just hiding. We'll create them for address and age as well. See, this is where I like to use the underscore, so I know this is the field and this is the value being passed in. And for age as well. Alright, so with these, we now actually have a way to make use of these variables. But to do that, we need to take a couple steps here. First thing we need to do is we need a variable to hold the class in. So use the class name. In this case, it's user, but that would be like typing int. So to create the variable, we still need a name, something we're going to call it by. Use lowercase user. Could be anything, could be Bob. Call it user. This is the one piece that will be different. So we can do this on multiple lines. Typically you'll see it on a single line. For user to be usable, we need to create a new instance or a new copy or a new box. So a new copy of the object or a box to place the data in. So I'm going to create a new user object. And now we can use it. And to access the members in user, or the methods, use getters and setters. It's going to be the variable name. And now you see we have get address, get age, get name, set, set, set. So we have the values, let's go ahead and set them. And let's go ahead and display the user. Just to show it in action. So we'll just use two of the pieces of information. We'll do user dot, we'll get the name. We'll get the address. And to make it simpler for testing, since we're not using this code for now, I'm going to comment out this part with the getInts. So now if we go ahead and run the program, enter a name, do Bob, 2 to 3 lives on Grew Way, and Bob is 120 years old. So you can see Bob's address is 123 Grew Way. So that works pretty well so far. The next item to be aware of with classes is there is a special type of method called a constructor. You know, the constructor, the name for the method will be, it matches the class name, in this case user. And the constructor is called once when a new instance of the class is created. And it gives you a chance to ensure that the values are set for any fields the class has before the programmer gets a chance to actually make use of the class. So you can prevent any issues if something has to have a value before the class gets used. You do that by declaring a method that the name matches the name of the class. There is no return type. If you take no parameters, that would be a default constructor. If you do not define a constructor for your class, C# will actually make a default constructor for you, which is the only reason that this call to new works. But the second you define any constructors for your class, it will no longer make a default constructor for you. So if we make a version that takes in an argument, so we have a version that only takes in a name, let's go ahead and set the name. What you'll notice is back in program, it no longer likes this line because now that we have defined a constructor, C# says, okay, you know what you're doing, I'm not going to touch your code. So it does not give you a default constructor anymore. the way to fix that is you either have to force the code to be updated, so that we would have to call it by passing in a name. So we can fix it by calling here with a name. It could be an empty string, could be Bob, whatever. Or you can fix it because, like other methods, you can overload it. So we can have multiple constructors. So we can define the default constructor and have one that takes additional parameters. Let's go ahead and take the rest of the parameters to make it easier when we create new users. So if we take in the address and age all at once, we can get them all initialized. By doing that, that actually allows us to simplify the code. We no longer have to call these sets. When we create it, we just pass in and that will work the same way. If we go ahead and run this, which I highly encourage running your code, write it in pieces so that you can run each piece, test it, make sure it works. And you see it still works just fine. Now this, if we had to make 100 users, we could actually make an array of users and just fill it out, and all the information per user is kept in one place. One term you'll hear mentioned is called instantiation. That means is you're creating an instance of the class. That's what we're calling new user. That makes a new copy of the object every time you do it. So if we did that 3 times for 3 different variables and set the name for one of them, the other 2 are independent and have their own copies of the name. Each object has its own copy of the name, address, and age. So if we have 3 objects, change one to Bob, one to Jeff, and one to Mike, you would have Bob, Jeff, and Mike. You wouldn't have 3 copies of Mike at the end of that. Let's see, the class definition acts like a blueprint, and that blueprint is what the compiler uses when you tell it to create a new user. Until we define it, the computer has no idea what a user is. A user is whatever we tell it a user is. And we do that through the class definition. The only way it knows what to do with a user at all is what we tell it. Another thing to be aware of is what we're doing here. I wanted you to see this can be done on 2 different lines. It could be done completely 2 different times. So just because you're creating a variable to hold an object, you don't have to put an object in it immediately. If you don't, typically for safety, you want to put a special value in there called null. And that is because we can use that later for safety to check against. So let's do that. The other option, what we could have done, is we actually could have done that all on a single line. Comment this out. I'll just leave it there so you can see it. Can do it like that. This is the form you'll typically see, but it's not required that you do it that way. And there are cases where you may not want to create an object because you're getting an object from somewhere else. Alright, so let's get a couple more pieces of information for the user. Let's do some program specific settings. We'll call them preferences. Let's pretend we're making an application like Facebook or something like that. We're going to have videos, so we need to know, should the videos autoplay and what volume level do they want what do they want the volume to be at. So let's go ahead and ask for that information. sorry, let's make a class to handle that information first. So we use Control Shift A. We're going to create a new class. Now I accidentally clicked too fast and just got the default of class 1. We can actually fix this. Come over here and just tell it to rename. And we'll rename that to preferences. It's going to ask if we would like to perform a rename in the project. I'm going to say yes. And that fixes the class name here as well. So now the file name is preferences, class name is preferences. It's all fixed. So the values we want to hold, we have a boolean for should videos autoplay. And a double for the volume level. Now, to make this useful, we should add getters and setter, or getter and setter methods. So we'll do that for both of these. The name is a little long, but it's a little more descriptive, so it helps if someone's reading the code later. They can see exactly what the code is doing, instead of trying to figure out what some cryptic method name means. And that shouldn't, since it's set, it shouldn't return. See the words coming up real fast. It's because if you type a few letters, you can look at the hints that come up from IntelliSense. You can see it's on should they autoplay, that's what I want. Hit tab, fills in, and so that helps you go a little quicker when you're typing. So that covers the autoplay. Let's do the ones for the volume. There's the getter. Let's do the setter. And let's go and make a constructor for this as well. Again, that's going to be the class name, no return, the values we want to take in, and the volume level, which is a double. I need to assign the values that come in to the fields. And that is enough that we can go ahead and create a preferences for our user in main here. So first thing we need to do is we actually need to get the values, and to do that I actually want to add a couple helper methods here. We're going to do the getInt, we're going to copy these, but we're going to create them for doubles. So we're just going to copy these two methods entirely, paste them down here, change the getInt name to double, make sure we change the return type to double, something down here, change the name to double, change the return type to double, change the validated int to double, and for the actual variable name here, I'm going to tell it to do a rename. That way we don't have to change it manually in 3 different places. And we need to change the int try parse to double. And then the same thing down here. That needs to be a double. You technically don't have to change the name, but for the code to make sense, and to be nice to anybody that might have to change your code later, and then we have to change this here to double. Okay, and then we should change the message here to just change it to enter a number, since any numbers are valid. And a lot of people, laymen, aren't going to understand if you say double if they've never had to deal with programming before. So I have those values to use. And we should do one more to handle Boolean values. I'm going to go ahead and place that one here. For this one, we're going to check true or false, get yes or no, and we're going to do that is we are going to get the Boolean value. I'll default it to false. We're going to need a string for input. I'm actually going to put one more value in here. Keep asking we'll use to control our loop. So we'll do this. We'll go I should change that to need a valid response. I think that reads a little nicer. So while we need a valid response, we're going to do this in a loop. At the end, we will return the answer. And inside the loop, we will ask the question. We use a right instead of a right line. The question is the message. We need to give them a chance to respond, which means input needs to catch the value of console read line. we're going to use a new construct. Anytime you would use like an if else chain, so we're going to do if something and then do an else if and an else. Basically, anytime you need to handle more than probably 3 or 4 options, there's another construct that's better. The keyword for it is called switch. With switch, you need a specific item to act on. It has to be something that either evaluates to a constant like a string or switch off like an integer value. In this case, we'll use the string, the input. And inside the switch is a block. With the switch, you define a block. Inside this block, you define what's called case statements. These are the values you're going to check for. So we're going to check for multiple cases for each one. So let's go with true. And typically you're going to have a block like this with a break. And then here's the code, whatever you want to do when that case comes up. So if they enter the value true, in that case we will set the answer gets true. And the need a valid response to false. So we are done, we have a response. And if we want to handle the false version, same basic idea, we're going to set up a case block. In this case, the answer's already been set to false, we don't need to change it. But need a valid response, no, we now have an answer. Now, to make this a little more helpful, we're going to handle multiple cases. What we can do is we can actually piggyback, since we want them to do the exact same thing. We'll also handle T for true. We'll use yes, and we'll also use Y as the responses we're looking for the positive. And just to make this look nicer, I'm going to change the order. What this does is, since they don't have their own unique blocks, it'll fall through until it enters the block and hits the break. The break says we're done, get out of the switch. Which the switch then, once it's done, you would hit the loop, comes back up here. As long as this has been set to false, we're out of our loop. If they enter something that doesn't match any of our cases, then it'll just keep asking the question again until they give us a reply that we can do something with. So we'll go case no, case N, and we have false. Let's go and add F as well. So now we have 8 different replies we're handling, and it's a lot more efficient than having to write an if check to handle every single one of these. Now the one piece we do need to fix, these case statements are case sensitive, which means if they type capital yes or all capital yes, or they do some funky weird case where some letters are capital, some aren't, it won't pick it up even if they're matching the string. So what we do is we're going to call an additional method on here called toLower, and that's going to take in whatever string comes back from readline. It'll call toLower on it, which is a method that will take the string, create a new version that has every letter lowercase, catch that, and that way we only have to handle the lowercase versions. We don't have to add a bunch of extra cases for weird stuff, like if they wanted to do, we don't have to add a bunch of stuff like that. When you're using toLower, one thing to be aware of is it's very easy to accidentally capitalize the first letter. Even if they type true, that will never match. So that's one common error to be aware of. So now we have a get boolean. We can use that to get our video question answered, and get double so that we can ask them for the volume. Let's go ahead and do those up here in main. We've asked the user for info and created a user. Let's go ahead and ask them for their preferences. Let's see, let's get bool, and we'll just ask them volume. We'll use 0 through 10 for valid values, which means instead of this version, we need to call the one that does range checking. And let's go ahead and run that because that's a lot of code. Make sure that everything works the way we expect. Videos on the page autoplay. So far that works. And that works. And we're showing the address. User's info. Still showing that here. So let's go ahead and create a preferences object now. And we'll pass in the values that we just asked for. We can go ahead and display those. So if we do that, we can actually go and run that real quick. And autoplay, yes, let's autoplay, and let's use volume 10. You can see autoplay value is true, and the volume is set to 10. So far so good, but now we have user, we have preferences, the preferences belongs to the user. It'd be nice if we could associate that with the user class, and we can. What we can do is use a concept called containment, which is where one class contains another class. It's also described as a has-a relationship. In this case, it would be a user has a preference or has a preferences. So what we'll do is just like we would make any other field, we're going to make a field that is of type preferences. And we'll call it prefs. And we'll treat it just like we would any other built built-in data type like string or int, so we'll make a getter for it. Class name is your type, so preferences is the return. And we need a setter. The parameter will be of type preferences. Set it like that. So now we have a getter and setter, so we can access and use that. So let's actually go and use that in program as well. So now we've created both. Let's go and take the preferences. Go user.set preferences. And we'll give it the preferences we created. Which means now, instead of using preferences here, we could actually get that from the user. And we wouldn't need the separate variable to hold on to that afterwards. So there we get the preferences, and then this is called on the preferences, the get autoplay, or should autoplay and get volume. If you had a lot of information you needed to do and you no longer had the preferences variable or object handy, you could create a temporary one here, call the user.get to get it, and then you just use the variable to call these. So if you need to, it could be like, if it was somewhere later in the program, this was no longer in scope, do that, and then here the call could just be temp dot. If you need to get a lot of information out, it saves some calls. So the last thing I want to talk about is helper methods. You have we've walked through creating some different nice methods down here for handling input validation. Instead of just dumping these in your program just anywhere, it'd be nice to keep them organized. Maybe use something that's designed to group related items to keep track of them. So with that in mind, let's create a class. Let's go ahead and call it validation. And what we're going to do is we'll go back to the program here. Go to the first getInt and copy all of these getInt methods. Actually, I'm going to cut them out. So the only thing here in program now will be the main method again. And then in the validation class, we're going to put those methods in here. And here they'll work just fine. Since they're static, we can access them from the class name. So in that, you will see some errors because it doesn't see the methods. Now, instead of calling them directly, since they're not in program, the only difference is we need to type the class name first. And the one part I forgot is we need to add the word public in front of these, because they're no longer in class. Alright, so put public. By doing that, if we go to the program, now we can call validation dot and get the methods. And while that does mean a little more typing, oops, of course I missed the last one I needed. There we go. So that does mean a little more typing, but it does also mean that your code is cleaner. If you need to look at, change, add, or remove any of the validation methods, you have a specific class to go to look at it. You're not hunting all over your code. And if you start a new program and you want to make use of that class, you can actually just copy it in, or you can just move a copy of that class into your new project, and you don't have to reinvent the wheel every time you start a new program. These are what I would refer to as utility methods. Another good candidate for being turned into a utility method would be these two lines here. I'll leave that as an exercise for yourself on moving those into their own class, maybe like a utility class, and maybe call it something like pause before continuing, something along those lines.